Standardization is a data processing technique used to transform feature to have a mean to zero and a standard deviation of 1. All of you can hear me, right? Okay. All right. So this is done by subtracting the mean of each feature and then dividing by the standard deviation. Standardizing is often used in data analysis and machine learning to ensure that all features contribute equally to the model, especially when features have a different units or scale. Okay, so basically here what we will do, for example, there is a graph I will show you. Suppose we have graph, normal distribution graph. We take mean as 0 and standard deviation as 1. Okay, so this is called standardizing. So how do we convert it? There is some formula we have here. So let me show you. Yeah, so this is the formula. Yeah, so this is the formula for standardizing. You can see x standardized is like x minus mu upon sigma. What is x? X is the original value. Yes, and mu is the mean. Original value mean divided by standard deviation. So this is how we standardize. Standardize. Okay, so we have some steps here for standardizing that calculate the mean first and calculate the standard deviation and then transform the data. Subtract the mean from each value and divide by the standard deviation. So this is how the we do. This is the step. Okay, so do we need to do this? What's the reason behind it? Okay, so reason is we can see over here equal contribution, like ensure that all feature contribute equally to the analysis or model, preventing features with a larger. तो बेसिकली यहाँ पे क्या करते हैं हम लोग कि वो कोई फीचर बहुत ज़्यादा डिविएट ना कर दे हमारे मॉडल्स को या कह सकते हैं हमारे एनालिसिस को, तो उसका स्टैंडर्डाइज करना बहुत ज़रूरी है, राइट। एक तो नॉर्मलाइजेशन भी होता है और स्टैंडर्डाइजेशन भी होता है, तो बोथ ऑफ देम इज वेरी नेसेसरी. Improved conversion in machine learning, especially in gradient based optimization algorithm, standardized data can lead to a faster conversion. तो डेटा जितना स्टैंडर्डाइज रहेगा उतना ज़्यादा हमारे मॉडल्स के लिए बढ़िया रहेगा. तो दैट इज वाई करना बहुत जरूरी है. बेटर परफॉर्मेंस एंड वी कैन से कंपेरेटिबिलिटी. दीज आर द सम रीजंस. तो हाउ टू डू इट, लाइक करते कैसे हैं इसको. द रीजन इज, लेट मी शो यू. बहुत सिंपल एग्जाम्पल समझाऊंगा मैं यहाँ पे. जी. और एकदम डमी डेटा लेके, राइट. So we can see here that suppose you have a data set of the following values for a feature. जैसे 2, 10, 15 हमारा ये डेटा हो गया. और हाउ डू वी फाइंड द मीन, उसका मीन निकाल लिया हमने. What was the formula? Again, x minus mu upon sigma. X minus mu और सिग्मा. ठीक है, तो हमारा यहाँ पे मीन निकल के आ गया, दैट इज द सिग्मा म्यू. वो हमारा निकल के आ गया. एक्स, व्हाट इज एक्स? सर प्लीज टीच इन इंग्लिश. या श्योर. I'm just using few words of Hindi. Okay. Yeah. Okay. Okay. Now standard deviation. How to calculate it? There is a formula also. Like divide divide each number with its mean, and then divide the number of elements we have. That is the standard deviation. We figure it out, and now we'll apply the formula on each of the data. Like for the 2, it will be 2 minus 15 upon 10. This is a 10. This is converted into standardized, right? So now this distance is according to the, for example, it is minus 1.29. What is the meaning of this? If we assume that mean is 0, it is minus 1. It is minus 1.29. It means it is somewhere here, right? So this is how we do. Minus 0.52. Yeah. Okay. So this is like we can say 0.52, right? So this is here. Okay. So को Python में कैसे code? How to find it in a Python? Let me show you. Okay, standardization which we have here. So first of all, import it, and then you have some data, reshape it. Why we reshape it? So that it is visible like a column. Let me show you. Let me print the X. You will see here. Just 1 minute. Yeah, see this. This is our X, right? So it was a linear data, and we have converted into something like a column, right? So it is very necessary to put in our data. Okay, then what do we do? So we will import our standard scalar, make it a in a variable, make it an object, and on that object, fit transform your x values. Whatever value we have x, so all the standardized values you will get over here. So this is your values, normal values, and this is your standardized value. Okay, so you don't have to do the calculation like what we used to do. Okay. Okay, do one thing. I am giving you some values. All right. I'm giving you some values. You try to do the standardization of this value. Yeah, this is your data. Okay. Now try to do it. You can use this Python code. All right. Give me five standardized values for each of the element here. Fast. Fast. You people have the Python code. Like you have the function. Just you can do it within a fraction of second. Anyone? Fast, fast, fast. I got no values. What happened? Is it difficult to understand? Okay, I got some one answer. Wow, Diksha did it. Minus 1.16. Okay, 0.3. Okay, she used, I think, this library. Very nice. Okay, so we have already have the some inbuilt function. You have to use it. Okay, don't do it manual. Another output. Okay, looks same. Amazing. Yes, good. Next thing we have is the p value. Okay, what is p value now? Okay, so p value or probability value is a statistical measure that helps to determine the significance of a results from a hypothesis test. It is used to assess whether the observed data can reject the null hypothesis. Uh, the p-value provides the probability of obtaining result as extreme as or more extreme than the observed result, assuming that the null hypothesis is true. See, it is we have first of all we can say we have two statements. Okay, uh, null hypothesis we can say, and then we have alternate hypothesis. Null hypothesis, and we can say alternate hypothesis. Yeah, there will be one statement here, one statement here. We can say suppose what kind of how does the statement look like? So I will tell you I'll tell you. Suppose we are doing test on some of the medicine. Okay, placebo medicine. Placebo means medicine which does not have the real effect on the body, but it is just for it just work psychologically, right? Okay. So we are saying here the null hypothesis means the first statement we are saying here is that before testing it is that there will be no change. We can say there will be no effect on the body after eating this if we apply this on the patient. Okay, second is a null then like alternative hypothesis is let's assume that we say there will be some change. Okay, so we'll do the test our test here. Just keeping this in mind, right? We'll do the test whether we'll see that is the placebo our medicine is really working or not working, right? So it depends upon the p values. If we're getting very less p values, we will say that we have to reject this. Means of course there is some change we see. But if the p value is greater than maybe you can say significance value, which is it could be different for different condition. Okay, like it could be 0.5. So then in that scenario, we'll say that our null hypothesis was correct. Okay, what I just said, let me write it one by one here. Key concept is null hypothesis. We can say over here, null hypothesis, default assumption that there is no effect or no difference. Okay, we'll assume that there will be no effect. But if we get after testing, we get some very high significance value, then we'll say that this alternative hypothesis might be true. Okay, hypothesis that there is an effect or a difference. Okay, before you make a test, there should be two conditions, right? on which you are performing test. Otherwise, what on what we are working. Okay, what is significance value? The threshold set by a researcher commonly it is 0.05. Okay, below which the p value indicates strong evidence against the null hypothesis. We have two statement here. We can say usually in the null hypothesis the things are same. You can say we assume that there is no change. Usually, what happens in the fields of this medical field, usually we have very less significance value, maybe 0.3, because we don't want much error, right? So that's why we take very less significance value. Okay, it is saying that if the p value is less than is significance value, like strong, then there is a strong evidence against another hypothesis, right? So it is this value says, suppose we are getting, for example, I'm saying significance value is 0.5 and we are getting 0.3, right? So this says that there is a strong evidence that against null hypothesis, leading to the its rejection. We will say that the things needs to be seen again and things are not same. Okay, we got some evidence that we have to reject the null hypothesis. So this 0.3 is very significant. The less the number, more it is significant. And if the p value is greater than 0.5, we'll say that it is we don't have much evidence to reject the null hypothesis. So we accept. Is it clear when we have to accept on when we have to reject the null hypothesis? Is it clear to you? Yes. Okay. Okay, so I'm showing you example over here. Okay, how to basically solve it using the Python. See, first of all, you have to import it, right? So you have two data, group one, group two. And what is the situation? two different groups to check the are they same or different. Yes, right, correct. Okay, we have two groups, right? And okay, so stars dot t test. We are doing t test over here. Group one, group two. You just have to pass the values. You will get two values in return. T test here and p values here. Okay, so alpha is 0.05 means this is a significance value. Okay. If our value if our value p value is less than this 0.5, we'll say that reject the null hypothesis, significant difference. Let's run it and I will tell you what is the p value for this. Let's run it. See, t statistic it is saying 4.3 and p value is 0.002. So we reject the null hypothesis. What was the statement of null hypothesis that they both are same, right? So we will say that they are not same. So we rejecting the null hypothesis. Okay, they are not same. They have some difference. Fine. Okay, so I will explain it in a more detail again. We take in one example for this p value because this is very complex concept, right? You will easily get confused over here. So let me give you an example. Okay, so we are taking some condition here. See this. Suppose you have. I'm explaining you with the help of a concept, right? Imagine a coin toys. We are doing. Suppose you have a coin that you think might be biased, right? You have a coin that you think might be biased. Biased means which gives uneven uneven result, right? Not the equal result. And you want to test if it's actually fair or not. It has an equal chance of landing head and tail or not. How to do this? You decide to flip the coin 100 times, right? If you do the test, then only you'll come to know. Huh? That's why. Okay, so what is the null hypothesis we'll assume here in this scenario? How to assume the null hypothesis? We can see here. The coin is fair. We'll assume this, okay, which is equal. Like we'll say that everything is equal. Probability of getting head and tail is both are same. Null and Alternate hypothesis is that coin is biased and it does not have an equal chance of landing. Okay. So this is saying this is biased and this is saying this is not biased. Very fair. This is how we set the statement. Okay. Then next, conducting the experiment. So you flip the coin 100 times and observe the result. Let's say you get 60 head. Okay, you did 100 times and you get 60 head and 40 tails out of all these 100 toss. Now you need to decide if this result is enough to conclude that the coin is biased. Sorry, this is tails, not head. This is tails. Introducing the p-value. Basically 60-40, like it is we can say this is a little bit biased, right? I think. Okay, let's see what the p-value can do us for us. The p-value help us to understand how likely it is to get a result like the one you observed or more extreme. If the coin were actually fair, in other words, it tells you the probability of seeing such an unusual result by the pure chance. तो मतलब बहुत ही अलग चीज होने की, अनयूजुअल चीज होने की भी प्रोबेबिलिटी कितनी है? दैट इज द थिंग, दैट इज द पी वैल्यू. Okay, we can say now. So in this scenario, how we will approach the p value? See this. Interpreting the p values, right? So how we'll do it? Low p value means 0.3 or 3%. 3%, if you are getting 3%, what is the meaning? This means that if the coin were fair, there's only a 3% chance of getting 60 head and 40 out of 40 out of 100 flips by luck. Okay, there's only 3% chance. This low probability suggests that your observed result is unlikely to happen by chance. So you might conclude that the coin is probably biased. High p value, for example, 50%. This means that if the coin were fair, there is 50% chance getting 60 head out of 100 flips. The high probability, this high probability suggests that you observed result could easily happen by chance. So you don't have enough evidence to say the coin is biased. Just if you get your p values less than 0.5, just say it that we have to, yeah, so like we can easily say that we have to reject the null hypothesis, and if the value is more than 0.05, we will accept the null hypothesis, right? So it's very easy. So how we will conclude here? See this. Deciding on significance level, before you start the experiment, you decide a threshold like 5% to compare the p-value against. This threshold is called significance value. If p-value is less than 0.5, 0.05, you can say reject the null hypothesis, the coin is likely biased. If the p-value is very greater than 0.05, so you say fail to reject the null hypothesis, not enough evidence to say coin is biased. So in easy way, what's the summary in the easy way? You can say that the p-value tells you how surprised you should be by your experiment result if your initial assumption, the null hypothesis, were true. A very low p-value means your results are surprising. Means your results are surprising and suggest that your initial assumption might be strong. तो आप कह सकते हो जो आपका जो null hypothesis है, like null hypothesis, the more will be p value, the more it will support the our null hypothesis, right? The high p value means your results are not surprising and support your initial assumption, right? जितना ज़्यादा होगा उतना ज़्यादा better null hypothesis के लिए. Basically ये भी बोलते हैं कि null hypothesis is the probability of getting the null hypothesis true. ठीक है? One more thing we say that what is p value? What is the p value? It is the probability of null hypothesis to be true. True होने की probability है. 0.05 या उससे ज़्यादा आ रहा है तो we can say बहुत ज़्यादा सपोर्ट कर रहा है हमारे null hypothesis. Okay, next thing is we have here, what is it? Next topic which we have to do, Bernoulli distribution. Bernoulli distribution is the most easy thing which we do. Okay, the Bernoulli distribution is a discrete probability distribution for a random variable which takes the value 1 with the probability p and the value 0 with the probability 1 minus p. It is one of the simplest types of probability distribution and is used to model scenarios with a two possible outcomes, success or failure. तो सबसे easy है, that is how we will do. Suppose we say that coin we toss the coin. So head आने की, what is the probability of head? 0.5. And tail 0.5 again, right? So this is your p and this is 1 minus p. So original p may, if you decrease 1, so you will get the probability of second half, right? Basically, it works only two values, 0 and 1. Or it could be anything like head, tail, yes, no, true, false. Formula is here. Yeah, so formula is we have here. Random variable, let x be Bernoulli random variable. We see that probability of getting the one kind of situation is p and another situation is 1 minus p. Very easy. Let's do with the help of Python. Okay, import numpy as NP and probability of success is 0.5. Maybe we are doing the toss here, right? So you'll write np dot random dot binomial. Okay, let me show you this first. It will produce 1,000 data. See, whereas the probability of one is 0.5, right? We can try different also like 0. Suppose if I write 0.9, you will see lot of one here, right? So you can see it is producing as a dummy data for us. Let us put only P. Okay, so what we will conclude from here, like find out the mean of this, find out the variance of this, calculate mean and variance. Mean is 0.5, variance is 0.24. And what is the variance by definition? Anybody tell me? What is variance? Deviation. Variance is the data deviated from the mean. Okay, what is the difference between a standard deviation and variance? Variance is a square deviation, and a standard deviation is a square root. Yes, correct. Variance we find out by squaring the errors, and the standard deviation we get by the doing the square root of the error. स्क्वायर क्यों करते हैं ताकि आपकी पॉजिटिव और नेगेटिव वैल्यू दोनों कैंसिल आउट ना हो जाए, राइट? एंड वी डू अंडर स्क्वायर रूट बिकॉज टू गेट द एग्जैक्ट वैल्यू. Standard deviation and variance. Right. So you can see this example also. X minus X mean. If you do the square, the things will not get cancel out. Usually have what happen? Like the things will get cancel out. कभी हमारा माइनस में भी हो सकता है प्लस में भी हो सकता है so you actually need these values, right? So what you will do, you want to place them in a same line, so you square them, right? Error का you do the square. बेशक आपको डबल वैल्यू मिलती है पर जैसे कोई आपके माइनस वैल्यू होती है दैट का स्क्वायर करोगे तो इट विल बिकम 1, राइट? तो वो भी हमारे पॉजिटिव साइड पे आ जाती है। बेसिकली अब आपका यहाँ पे डेटा क्या है, डबल हो जाता है ऑलमोस्ट। इफ यू डू द स्क्वायर रूट ऑफ दीज एरर्स you will get the actual value like this one, like the original one, but in a positive direction. Okay, see the time is we have covered a lot of things today. Time is we have limited, all right? So in the next session we will be doing what we are left with: power law, binomial, and normalization. Okay, I think normalization we left in the last class, right? So we'll cover in the next session. Fine. All right, students, have a good day. Yeah, welcome.
Thank you so much, sir.